So today we are going to discuss about hierarchical clustering. Okay. So hierarchical clustering is one of the most popular clustering algorithm, and it uses partitioning method. Okay. It uses partitioning method. So let us consider a sequence of partitions of n samples into C clusters. Okay. Let us consider a sequence of partitions of n sample into C clusters. The first of these is a partition into n cluster, each cluster containing exactly one samples. So each cluster at first will be having the first of these is a partition into n clusters, each cluster containing exactly one sample. The next is a partition into n minus 1 cluster. That means first you will be having n clusters, then the next is a partitioning. So first, how this hierarchical clustering method works, it works like this. First of these is a partition into n clusters, then next is to partition n minus 1 clusters, we do partition n minus 1 clusters, and then next is n minus 2 clusters. Okay, and so on until the nth, in which all samples from one cluster. That means finally we will be having one single cluster which will be having one sample from one cluster. Okay, we shall say that we are at level k in the sequence when C is n minus k plus 1. So we can say like that. So first n clusters, then n minus 1 clusters, then n minus 2 clusters. Okay, and then finally we can write that, finally we shall say that we are at level k in the sequence when C equal to n minus k plus 1. Thus level 1 corresponds to n clusters, level 2 corresponds to n minus 1 clusters, okay. So given two sample x and x dash, therefore just we are discussing what is hierarchical clustering, then we'll get into that this dendrogram and agglomerative clustering. So let us try to understand. Given two samples x and x dash, at some level they will be grouped together in the same cluster. So given two samples x and x dash, at some level, not same, at some level they will be grouped together in the same clusters. How they will be grouped, that we are going to see. So if the sequence has the property that whenever two samples are in the same clusters at level k, they remain together at higher levels also. Okay, so what is the next point? Next point is that if the sequence has the property, if the sequence has the property that whenever two samples are in the same cluster at level k, they remain together at all higher levels. Then the sequence is said to be, then that means once it is grouped, any 2 points are grouped in a particular level k, it is believed that in the higher level also those two points at least will be in the same group. So then the sequence is said to be hierarchical clustering. Okay, this is the definition of clustering. Meaning is that we have levels. Okay, we can start with the n points, and then we'll group them together based on the similarity. That means which are the 2 points nearer. Based on that, you can group them together, and each level this grouping will happen, and finally you will get a cluster. So that will maintain the hierarchy. That means in each level the points will be merged together. That's why, and these levels will be continued further until you get a clusters, until you get the final results. Like let us say if you want that clustering to be happened in the result has to be happen in 2 clusters, you will end up in 2 clusters. If you want a single cluster at the end, you can also have a single cluster. Okay, now we are starting a little bit from the scratch so that we can understand in a better way. So next point is the most natural representation of hierarchical clustering is a corresponding tree. Next is natural representation of hierarchical clustering is a corresponding tree. That means how we are going to make the hierarchy using a corresponding tree called dendrogram. Which shows how the samples are grouped. Okay. This is what the representation is, dendrogram. Okay. Now let us take one example. Let's say we are not coming to the agglomerative or divisive clustering. We are giving the definition of, we are discussing about the hierarchical clustering, how this concept comes up. So let us say that we have 8 points. Okay, when the real-time application of hierarchical clustering will come, it will be assumed that the points will be in d-dimensional space, and points will be in terms of feature vector. Okay, but here we are considering points. Let us say we have 8 points. Okay, and let's say this is the level k equal to 1. So in kth level 1, nothing much happened, because these all are singleton clusters. Each and every these instances are nothing but points. Nothing is a singleton, you can say. Okay, so kth level, this is the k equal to 1 level, this is the situation, and then k equal to 2, k equal to 3 level, what is happening? Let's say x2 and x3 are grouped together at level 2. And let's say at level 3, let's say x2 and x3 is grouped together, and then let's say in level 3, let's say x7, x6 and x7s are grouped together. Okay, then let's say, so here we can write like this: level 2, level 3, then level 4, level 5, level 4, let's say x4 and x5s are grouped together, and and then with that, let's say x7 and x, whatever the result is, that is also getting grouped together. And then finally, let's say k equal to 6, k equal to 7, k equal to 8, x1, and this x2 and x3, they are grouped together. So level 4 and level 5, such kind of things happen, and these two group together, and with that, this result x8 is grouped together. That means the result of merged result of x4 and x5, merged result of x6 and x5, whatever the merged result of them, that has been grouped with x8. Okay, and then finally this all has been grouped together, and you are getting a single cluster. Okay, so this is what happens. Now next, so how this grouping will happen? This grouping will happen based on the similarity. So we remember this figure. Let's say this is figure 1. Here we have a scale which starts from 0, let's say from here. It should be straight line, but it should be straight line only. So this is a similarity scale, you can say that. So it's 0, 10, 20, 30, 40, 50, similarity scale. Okay, so here you are showing that one dendrogram or simple problem involving 8 samples x1 to x8. K equal to 1 shows the 8 samples are singleton clusters. So at this point, these are all singleton clusters. Okay, at level 2, that means this level, x6 and x7 is merged, grouped from a cluster, and they stayed together at all subsequent levels. If it is possible to measure the similarity between the clusters, then the dendrogram is usually drawn to scale to show the similarity between the clusters that are grouped together. Okay, so you understand. So here these clusters and these clusters are grouped together, and maybe their similarity is 60%, like that. Okay, so for example, similarity between two groups of sample that are merged at level 5 has a value of roughly 60. Okay, similarity between two groups of sample that are merged at level 5 has a value of roughly 60. Now the vertical axis shows a generalized measure of similarity among clusters. Here at level 1, all 8 points lie in singleton clusters. Level 1, all 8 points lies in singleton clusters. Each point in the cluster is highly similar to itself of each point is highly similar to itself, and let us say point x6 and x7 has x6 and x7 happens to be the most similar and are merged at level 2, x6 and x7. So this is, let us say this is 90, similarity value is 90%, and it has happened at x6 and x7 at which level? At level 2. So level 2, x6 and x7 has been merged, and their similarity is the highest. So this is how this hierarchy is actually being structured. So that's why you call it hierarchical clustering. Okay, we call it hierarchical clustering. Now this is a dendrogram representation. Okay, it's a dendrogram representation, and there will be a similarity measure value also in case of hierarchical clustering. So how that similarity measure has to be calculated, that we have to decide. There are different techniques by which we can measure the similarity between 2 points or 2 clusters, or 2 clusters. So basically, if you see, this dendrogram represents nothing but a binary tree. Okay, there is no you do not need any intelligence to say that this is nothing but a binary tree. So this is how we should represent. We can represent the hierarchical clustering in terms of dendrogram. Now it is not always the case that we have to represent the hierarchical clustering in terms of dendrogram only. Okay, so let's say another representation for hierarchical clustering is based on, actually I should write it can be based on sets Not always that you should represent the hierarchical clustering in terms of dendrogram. We can represent in terms of set also, in which each level of cluster may contain sets that are subclusters, such as below. So let's draw a below figure through which we will understand how we can represent in terms of sets. So sets representation of hierarchical clustering. Okay, this might be a new information for you. So anyway, so let's say this is my larger cluster, singleton cluster, which will get at the end after merging all the subsequent clusters in a hierarchical fashion. And let's say it is taking a little bit of time. Let's say these are my points. Okay, so this is this is a representation of hierarchical clustering using sets, where the number of points are 8. So we can use brackets okay. So these are all value of okay. So here what happens, x1, with x1 we are merging x2 and x3, okay, and then we have x4, this is there. With that we are merging this one. So this x7, this seventh cluster, we have x4 x5 merged together, okay, and then x6 x7 we have x6 x7 and x4 x5 are merged together, they are being a single cluster, okay. And that is yeah, and then finally these two clusters are merged together. This one it has, and then it has again merged with this one, and finally we are getting x8, okay, and finally we are getting a cluster. So this representation may reveal the hierarchical cluster of the data they do not. So here one point we have to mention that this representation may reveal the hierarchical structure. So this set a problem is that it reveals the structure of the data. Structure of the data. They do not naturally, the set representation of hierarchical clustering, they do not naturally represent the similarities quantitatively. Therefore dendrograms are preferred. So why dendrograms are preferred over set? This may be a discussion, and you can answer like this, that this set representation has some problem. It doesn't represent the quantitative aspect of it. However, visually we can say that what is the hierarchy. Visually we can, seeing this thing, we can develop the hierarchy of the clusters by which it has developed the final clusters from the starting point, starting n number of points, 8 points, but it doesn't reveal the quantitative aspects of it. Quantitative aspects, that means how much similar two clusters here, x1 with that x2 and x3 has been merged. What is the similarity? How much similar that we have merged this x1 and the result of x2 and x3. So this is the thing. Okay, so dendrograms are preferred. So representation wise, dendrograms are preferred. Now so because of the conceptual simplicity, hierarchical clustering procedure are among the best known of supervised method. So hierarchical clustering is obviously supervised method, and it is one of the best known supervised method. Okay, supervised methods. Okay, and the procedure themselves can be divided according to two distinct approach. Now we are talking about the approach, how to find the hierarchical clustering. What are the approach? So first approach is agglomerative approach, and second approach is divisive approach. First approach is agglomerative, and second one is divisive. Agglomerative approach sometimes referred as bottom up or clumping, and divisive approach referred as top down splitting. Okay, so